Welcome to the Profile Area Talent Talks 26. With the RWTH Speed Funds, our top talents bring their vision of interdisciplinary cutting-edge research to reality.
In my master's thesis, we considered the problem of understaffing in hospitals. When understaffing occurs, nurses feel overwhelmed and patients receive insufficient treatment. Our goal was to solve this problem by looking at the schedules and trying to improve them such that the understaffing is minimized. I could spend 6 weeks in the Netherlands, where I worked together with the Choir Group. This is a group who works closely with hospitals to improve the care and also the well-being of nurses and patients.
In my master thesis, I conducted numerical simulations on a human head model, which included all relevant anatomical structures of the auditory system. And I used this model in order to investigate the occlusion effect, which is an effect that often leads to huge acoustic discomfort for people who have to wear hearing aids or hearing protectors. And what I did was that with the help of RWTH Speed Funds, I was able to conduct a 2-month research stay in Montreal, where there's a team which has very special expertise in this field, and I was allowed to use their computational resources and to present my master thesis results at the DAGA Acoustics Congress in Dresden.
My research is regarding the production of the solid-state electrolyte LZO for solid-state batteries. Solid-state batteries will introduce higher energy densities, making a car, for example, driving a larger range with the same volume of battery. LZO cannot be produced at the moment on large-scale production machines, but my idea was to use conventional lithium-ion production machines in order to have an easy transfer from lithium-ion battery technology to LZO. Therefore, I produced separators and conducted further research on the conductivity of it, for example. The money from the Speed Fund supported my vision, as I was able to buy materials and machines and go on a conference in Orlando to talk with experts about my ideas.
As we grow older, everyone wants to live an active and healthy life until the later years. However, with declining physical abilities, we need technical innovations to support us. At the Chair for Medical Information Technology, we are researching exactly these solutions within the field of gerontotechnology. A prominent example is the assistive exoskeleton, which compensates for reduced muscular strength and supports everyday activities.
The development of exoskeletons for elderly brings a few particular challenges. Firstly, the gait of elderly people is prone to falls, so we need a lot of sensor information to measure the gait precisely, especially in the feet. Moreover, the cognitive and haptic abilities of elderly people are degraded in comparison to younger people, so we need an age-appropriate donning and user concept. Lastly, the skins and bones are more brittle compared to younger people, so we need a soft and fluid force transmission from the exoskeleton to the user to have a benefit for the elderly while using the exoskeleton. This requirement led to the master thesis of Carlo Jacob.
My thesis soft actuator for exoskeletons was about designing a variable stiffness element for the exoskeleton's knee joint. To kind of grasp the concept of variable stiffness, we can compare the human joints to robotic joints. Because human joints are already variable in stiffness. So if you keep the muscles loose, the joint is also loose, but if you contract the muscles, the joints turn stiff. Robotic joints, on the other hand, are constant in stiffness. This is great for precision, but when man-machine interaction comes in place, we need the robot to be also compliant to increase more safety. And therefore we designed and built a pneumatic damper for the exoskeleton leg. Because if we increase the pressure, the stiffness increases, and if we lower the pressure, the stiffness lowers. But now the damper needs to know when to turn stiff and when to keep loose. Therefore we used a sensor kit in the sensor shoes to perform a gait phase estimation and an intention estimation of the human in there. And thanks to the Hans Hermann Voss Foundation, we were able to actually build the exoskeleton leg instead of just landing in theory. For future work, we will also need to design proper control algorithms for the whole exoskeleton to make it safe and ready to use.